welcome to Wing Design Tutorial 2, Designing Wing Parts using Solidworks. The objectives of this tutorial are to transfer aerofoil geometry data from Excel to Solidworks, then to create a master sketch for the wing cross-section geometry, then to generate individual parts from this master sketch, and then finally create a new Solidworks material and apply it to these new parts. Okay, so here we are in the Excel design spreadsheet we left off in tutorial 1, and what we need to do is get the aerofoil coordinate data from this and export it so we can get it into Solidworks. So I'm going to go to the last tab on this spreadsheet, and this is the aerofoil data that we produced there, and it's just put on its own tab. It's a little bit fussy getting Excel to do this, but the way to get this data out is to do File and then do Export, and then we want to change the file type and we want to change it to Text Tab Delimited. So now we do Save As, and it'll come and ask for a name. I'm going to overwrite this file, so this is the name of the aerofoil and .text, so you can call it whatever you like as long as you remember what you called it. And so what we're going to do is just export the text data for that aerofoil section. We do Save. Mine already exists, that's fine. Then it's saying multiple sheets, blah blah blah. We just ignore this on Excel. I'm not quite sure why it has to ask that every time. So we've now, if we look up at the top here, we can see it's saved as the aerofoil name.text. Doesn't matter what you call it, but it should be a text file, say, to this PC. And then the next step is you have to close it because you can't open it in another application when it's already open, so make sure you close it, and then ask you to save, and it's already saved. I don't know why it does this, so I'm going to save it again. It's going to want to overwrite it. So it's a bit funny exporting stuff from Excel, and you have to be a bit careful that you don't overwrite your existing files with that, so just keep your wits about you when you're doing it. So here we are in SolidWorks. I'm using SolidWorks 2023, but this should work pretty much in any version of SolidWorks that you want to use. The only caveat being, if you're doing group work, make sure you decide in your group to use a common version, that you all use the same version of SolidWorks. Files are forwardly compatible but not backwardly compatible in SolidWorks. To get started, I'm going to start a new part, so click on the blank document, double click on part, and it opens up a blank document. First thing I'm going to do, good housekeeping, is I'm going to save it, and I'm going to find a sensible place. So this is SolidWorks Wing Tutorial version 2, that's fine for me. I'm going to save it in that directory, and I'm going to call it Wing Geometry Master Sketch. And the reason we're calling it as a master sketch is that this curve file we're going to use to generate all the other parts of the wing. So it's a master sketch in the sense that a lot of other parts are going to be using it. It sounds like a fancy name, but it's a way of storing all your geometry in one place. Okay, let's get that curve in. So we do Insert, Curve, Curve through XY points. Then we need to browse to that file that we've just saved. First thing it does is it's looking for solid curve files, which is not what we saved it as. We saved it as a text file, so change that to text file. And if you look down on here, I'm on my quick access folder. You may have to navigate to yours, but mine's popped up straight away, NACA4418.txt, so I know that's the file I want to use. If it's gone well, you should see some numbers appear here. If you've left your file open, it will come up with an error saying it can't access it. If you've, well, there's lots of other things that can go wrong in that chain. Anyway, if it's gone right, this is what you'll see. You'll see some X, Y, Z numbers, and it's taken the numbers from the spreadsheet and it's imported it into here. It's added millimeters on here to show you that it's got units. So that's all good, and we can actually see a yellow preview of the curve that's coming in. So we do OK. And now that comes into SolidWorks and it appears here as a curve object in our feature manager tree. So it's not a sketch or a part or anything, it's just a curve of data. Sort of disappeared on the screen, but to be able to use this in a sketch, we now have to then basically bring this across into a sketch. So what we're going to do is create a new sketch, and if I'm just looking at my triad down here, remember our coordinates were in the XY plane. So what we want is something on the XY plane. If we just check our planes, that's the right plane, so that's not that, that's the wrong plane as such. Top plane's not right. Front plane, is the one lined up, and it's in the XY section. So we're going to draw our sketch on the XY plane. If you use a different plane, it'll all come out funny. You can always fix it afterwards, but it's better to use the right plane to start off with. So I'm going to right click on that. You can do new sketches by many ways. Then I can do new sketch. So this blue thing in the background is the curve, it's not actually the sketch. And so what we need to do is bring that in. And the way to do that is you use something called convert entities. And it's asking me which entities I want to convert. And if I click on that curve and do right click, bingo, we've got it. So these black lines is now a geometry within our sketch that we can use. Some little jobs we have to do. First off is the sketch is not closed, so it's got a flat trailing edge, so that's kind of useful for us anyway. So first job I'm going to do is join up that line. So I'm going to do click new line, and I'm going to make sure that it snaps onto that first point. So you can see that little yellow target thing appear, so I know I've got that. So my line pulls off from there, and then I'm going to go over that other point, wait till it snaps to a yellow target, and it's on. And I can tell I was successful there because this whole thing went grey, sort of flood filled, and when Solidworks detect a closed shape, it fills it with a colour. It's very easy to do this and slightly miss, and it may look like you've connected it, but you haven't. If it doesn't go filled, you haven't connected it, so you have to have another go at it. Great. What else do we need to do? This is a spline curve, so it's a special type of curve, and it so happens that when we're going to try and do some offsets on this, and Solidworks doesn't like you trying to do it all in one go because the trailing edge is too sharp. So we've got to do a slightly fiddly thing, but we've actually got to split this curve into two. So this is our spline. You can see my cursor goes to a little wiggly snake thing there, and if I right click on this and then go down to sketch tools and then split entities, click on sketch entity to split, and I'm just going to split it at the origin there. I'm just going to click on that, and it's coming out with confirm delete constraints, blah blah blah, deleted. Do you want to continue? Yes. And now that I've done that, and I can click out of that, we've now got two curves, a top one and a bottom one, and that's quite a useful trick when you're working with splines to be able to split them. Okay, what should we do next? We've got a spar from our Excel file, so let's get that open. So here we are back in Excel. I'm just looking at the spar I designed. It is 50 by 50, and I tell you what, I'm just going to be lazy and turn that to 5, because that makes it easy for me to draw. I'm just going to do a box 50 by 50 by 5. Clearly this one doesn't meet the structure requirements, but this is just to demonstrate how you draw stuff. Okay, let's go back to Solidworks, and what we need is a spar that is 50 by 50 and 5 thick. So get some smart dimensions on there, drag that up, that's 50, that's 50, and at least you can see why I did it at 5mm, but the easiest way to make a box there is if you do offset entities, and we're offsetting this. Let's select the chain, and we want it to go inside, and we want it to be 5mm, and construction geometry, it's all going to be real geometry, tick. And that's drawn that for me. If you've not used offset entities before, there's a few little things you have to work out, but it's a great way of doing shells and everything else quickly. The other thing we're going to need, it's really useful to have a center point in here, just because we'll need it to define an axis, and also for positioning perspective, positioning it within the wing. So let's go add a point. So I'll just click randomly, put it anywhere in there, and now tick that. I want to align it with the center. So there's various different ways of doing it, but the best way of doing it is if you just click the point, hold shift down, find the center of the line you want to go to, and then a little option will come up, make horizontal. So that's good, tick that. Same again, click the point, holding shift down, find the center of that, and this time we want to make it vertical. So now that point is constrained to be exactly in the middle of the spar. Need to get it in the right place relative to the leading edge. So if we go back to our spreadsheet again, and on our check geometry thing, we can see after fiddling around, and you're going to have to get this in the right place for how you want it, but the way I left it, it was at 112.5 millimeters from the leading edge. So let's put that in, 12.5. And the Y distance above the origin, the leading edge, was 7.5 millimeters. And let's tick that. Because that's quite small, what I'm going to do, instead of using a smart dimension, I'm going to do a vertical dimension, and I know it's going to work properly. So that forces it to be 7.5. Okay, good. We've got our spar in our wing. Not too worried right now how it fits. I'm hoping that when you do your spar, it'll be more optimally placed and what will height. I'm just showing an example geometry here, so don't consider this as a model answer. It's just I'm showing you geometry, and there's much better ways of arranging your material. Okay, what else do we need? We've got a trailing edge flap, so let's do that. I just moved it accidentally, so if you hit spacebar you can go back to views and select another one. So let's put the trailing edge flap on. I'm going to start at the bottom, and I want a vertical line, so you can see the little yellow cross thing, a yellow target thing appearing again, so that means I'm connected to that line. I'm going to go straight up. You can see that the yellow things I've got straight, and I'm connected to the other line, so I'm good, and I can select that. If you want to stop a line, just double click in space and it will stop it. We know that the trailing edge control surface is at 25% chord, so we could try to work out what all the numbers, but actually what I'm going to do to make my life easy is I'm just going to dimension the chord here. We'll get Solidworks to do that. So we're not going to change that, that is the dimension, but we want then this distance to be 25% of that. So I'm going to take the back of that, and I'm now going to use effectively an equation to define that. So I'm going to do equals, then I'm going to click on the chord of the wing, and then times 0.25, so that's 25%. Tick that. So what that is, that dimension now, there's a little sigma sign in front of it which shows it's an equation. It's just a smart way of using Solidworks. Rather than calculating it, you just, or rather than working it out, you actually just use get Solidworks to work it out for you. The other thing we're going to need is a cutout there to allow the control surface to move, and let's allow the control surface to move 30 degrees. So I'm going to put a dimension on that. 30 degrees. Okay, that's looking good. Okay, so the other things we're going to need is a spar to hang the control surface off, and we're going to need a leading edge shape there to make sure that the front of the wing is properly defined by the geometry. So to do that, I'm going to do some offset geometry from the shell shape. So what I'm going to do is offset geometry, and I'm going to click on that shape. It's gone select chain, so it's gone all the way around. It's on the outside. I want it the inside of that. Reverse, so that's the inside of our wing. And construction geometry, I'm going to do the offset geometry as construction. So I don't want that to be a solid line. I want it to be a line I can use then to guide what else I'm designing. So if we've done that, tick it. What you see there, it's now a 5mm offset. Remembering foam mill is 5mm, so that's why I've done it as 5mm. And it's a dash dotted line, which means it's for construction. Means I can use it, but when you start extruding parts, it's not going to get in the way. We're going to do some work on these bits to make them useful parts, and I'm going to do some offsets on these as well, just to help make my life easier. So I'm going to click on that, do offset. I don't want to select a chain, and I want it the other side, 5mm. That's good. And I'm going to do the same on this one, where I'm going to do offset, and it always does it the wrong way. But there we go. There's another offset there, and we can use that. Okay, let's draw the trailing edge spar first. So I get my line tool, and it doesn't matter exactly how big this is, but you need some sort of C-shaped structure on the back here. So I'm going to click on that, making sure it's connected on that line, go to the join of those two, somewhere back here. And so the geometry is not critical for this, it just needs to be a sort of generic C shape. Double click an empty space to finish it. That's okay. While we're here, let's finish off this. So this is going to be made out of foam board, so we want it to be a 5mm shape that we can fold up into a sort of triangle. So let's cut out the middle of this triangle properly. If you notice, when I made that triangle, it went a different colour grey because Solidworks recognised I connected it all up. If I'd missed any of that last point and it hadn't joined up, it wouldn't have gone grey. This one hasn't gone grey because we've used different lines to do it, but we'll check in a minute that it's worked. The other thing we need to do is a leading edge part, because you can't, if you're covering this, you can't just have film coming around a curved edge like that. It'll collapse in the middle. So let's do the same here. It's not particularly critical where you put these, it's up to you. Let's do two of these things on either side. So all I need to do now is join these curves up, and the easiest way of doing it is just to draw another curve on top. And then what I'm going to do is use a spline, so the snake icon here, and click on the first point, do my intermediate point there where the leading edge is, and another point there. You can see it stretching out, and click there. In fact, I need to double click on that last point. And you can see some spline handles and things here, but actually the way it's done it by default is actually alright. So that's a curve that we've used for the leading edge. Okay, so this is going to be our rib. Because we're aerospace engineers, we make things as light as possible, and this rib probably is overstrong. I'm not really doing any analysis on it, but there's a lot of material there. So what I'm going to do is just put some lightning holes in and say this is more art than science, but I'm just going to basically cut some holes in it. I'll do, this one feels like it's slightly too big, so I'm going to make it a bit smaller. Move it up that way a little bit. That one's a bit too far across. Okay, that'll do for now. So what we've got here is all the geometry we need to make a wing, and so we can extrude parts off all these different bits of the sketch. And the value of having it all in one place is that we do all our detailed design work here, and then this will flow into the other parts. And to check our sketch is watertight, what I'm going to do is just go up to features and then try do an extruded boss base from this. So what it's going to do is ask me which contours I want to do. So let's just check if we do the rib. So click in the middle. It's kind of magic, isn't it? You can see it's extruded everything off in the middle. So that's working. So maybe we want to make just the trailing edge spar. So if we pull that off, that's our spar coming out. So you get the idea of how you make these things. So we could also add in actually the control surface. So that sketch is controlling all the geometry, and depending on how far we extrude it out, we can make things like ribs and spars and all sorts of other different things. And just check our spar is working. Yeah, it's pulled out there. So there we go. We've got our sketch watertight. Chances are the first time you do it, your sketch will not be watertight. There'll be bits where you've got the wrong line types, or the points don't join up. So it can be a little bit frustrating to start off with. If your sketch gets into a bit of a mess, it's quite often just quicker to delete it and start again. Trying to find out little tiny bits where you haven't joined up is a bit difficult. But yeah, you may have to do it a couple of times. But when you've done it right, these things should extrude out properly. What I'm going to do is actually delete that because we don't need that right now. But notice, so when you delete that, oops, delete the name, delete the object, do on delete, yes, delete that. Solidworks is reasonably smart that when it deleted there the extrusions, it didn't leave the sketch underneath. And actually, while we're here, all I'm going to do is actually rename this as master sketch once again, because it's a really important sketch, and so I'm going to give it a name. Okay, so let's generate some parts from our master sketch. So what I'm going to do is make sure that's saved, and I'm going to do create new part, and as usual I'm going to save it first, and let's make the kind of rib section first. Let's call it rib. We're saving in the same place as the master document, that's fine. And to get this started, what we're going to do is insert parts. It's a little bit weird to create a part and put a part in it, but this part is essentially our master sketch, which is going in there. And it's the only file I've got open, so it's selected it automatically, so that's okay if you tick that. So now we've got our rib solid part, but it's got that sketch that we created in it. So let's make the rib from that. I'm going to make sure that sketch is selected so it knows, Solidworks knows I'm using that, and I'm going to do extruded boss base, and as before, selected contours. I'm going to click somewhere in the middle of the rib area, and the preview there shows it's succeeded. And as I said before, if your sketch isn't watertight, it won't succeed, and you need to tighten it up. Foam board is 5mm thick, and there we go, we've got ourselves a rib. We can still see the sketch in the background. I kind of don't want to see that anymore, so I'm going to do the hide thing, and there we are, we've got our rib. Great, save that. Let's do the next part. So let's do the spar next. Same process as before. I'm going to save it before I do anything else. Spar, insert part, master sketch, and make sure it is selected, extruded boss base, and click on that. But this time, in terms of the length, what we want to do is use the full width of the foam board, so the sheet length is 841, so let's make the spar the whole length of the foam board. So let's put 841 in there. There we go. Tick that, hide that sketch again, do another save, job's good. Keep going. Let's do the trailing edge spar next, or rear spar. Same process. Insert part, wing geometry, master sketch, and extruded boss base. Okay, so that was an example. I wasn't actually clicked on the sketch, so you do need to actually be clicked on the sketch for it to detect it. And we're doing the spar at the back, but this time we want it to be the length of the wing as specified in the requirements. So if we go back to here, we know that the semi-span for what I've set up, and bear in mind your numbers are going to be different to this, my semi-span is 0.75 meters, so that's what I need to use. So that's 750 millimeters. Okay, that's good. Hide that. Save the part. Let's keep going. So we need to do the leading edge. And that's the same as the back, so that's 750 millimeters again. And the last thing we need to do is the flap, trailing edge controls. But if you remember, we've got two flaps. We've got an inboard flap and an outboard aileron. So what we want here is half the length. So you can do maths in these boxes as well. So if it's 750 millimeters, we want half of that divided by 2, and it'll work it out for you. Okay, and there's our control surface. Save that. Great, so we've made all our parts, but as they stand now, they're just made out of ordinary Solidworks material, so basically not specified. And in preparation for the next stage, where we're going to put it together in assembly and everything else, the right time now is to apply an appropriate material to these parts. So what I'm going to show you now is how to create a material in Solidworks and apply it to these parts. We'll use this one as our starting point, but once we've created a material we can apply it to all the other ones, but the process is the same. So we go to material, right click on that and to edit material. A big database of stuff, mainly steels and metals and things, come up, and somewhere down the bottom there'll be a folder called custom materials, and it'll be different depending on how you've installed Solidworks. But essentially you can add new materials to the custom materials folder, and if you keep going down, and I've actually got one I've created here before, so what I'm going to do is, so let's do this one with nothing else in it. So it's my second custom materials folder, and what I'm going to do is if I right click on that, I can do I can't do a new material, it's actually got to be within a new folder. So what I'm going to do is create, so let's create a new folder here, new library, new category, and let's call it wing design. It's a little bit clunky the way Solidworks does this. You have to sort of create your own folders, and then finally when you've got to a folder, then it'll have the option to create new material. So it's right at the bottom you get the option to create new material. So if you can't see new material in your menu, it means you haven't gone far enough down. And it doesn't actually matter where you put it as long as you remember where it is, and actually if we create it as a default, it's even better. So it's giving me a thing, so let's call this 5mm white foam board as our material. And the reason 5mm is not part of the material stuff, but actually the 3mm stuff is a different density, so we're calling it 5mm so we know exactly what we're talking about. Okay, and now we've got to put in our values here, and what I'm going to do is get my Excel document up on a separate screen so I can transfer them across. But so what we're going to do is use these material properties here. Okay, so I'm going to add my material properties. So the first thing I need is elastic modulus, and one thing you notice here, there's a lot of zeros and it's very easy to be out when you typing them in. So the top tip here is use scientific notation. So I know my Young's modulus is 1.8 times 10 to the 8 newtons per meter squared. So I can type that in, 1.8, using the notation E, so does it mean exponent, 1.8 times 10 to the 8, and then it puts all the zeros back in for me. Poisson's ratio is the kind of to do with the way when you stretch something, how does it pull in the other direction. We'll just leave that. It's around 1/3 for most materials, so we'll just leave that as it is. It doesn't make a huge amount of difference for us. So shear modulus, so elastic modulus is the stiffness in pulling, shear modulus is the stiffness in shearing, so we'll need that because our beam will be shearing as well. So looking up on the spreadsheet again, I can see our shear modulus G is 2.1 times 10 to the 7. Mass density, so what's the density of the foam board, and looking at my spreadsheet I can see we've got 58 kilograms per meter cubed, so a meter cubed of foam board weighs 58 kilograms. So that's the weight of a person, so cubic meter of foam board weighs as much as a person. Tensile strength, actually we don't need this because it's going to be used, you only use it in automated calculations. I can put it in just because we've got it. So the ultimate tensile strength is 1.3 times 10 to the 6. And our compressive strength is 1E6. And when you do some modelling, you can actually sometimes use these and it'll tell you you've exceeded your stress value, but we'll put those in just because you might use them. Thermal conductivity we're not using, specific heat we're not using any of those, but it doesn't matter, we can just leave those in. Okay, category, wing design, name 5mm white foam board. That's good, we've got our values in. Check you've got the right number of zeros. It's really easy to be out by a factor of 10 on all these things. Let's press apply just for the hell of it. So the other thing we want to do is add this to our favourites, so it's at the top of our list, so it's nice and easy to apply. So what I'm going to do is go to favourites and then do add, and the one we've just created appears there, and let's move it all the way up to the top. 5mm white foam board wing design. So these are some of the other ones I created earlier, but this is the one we just created just now, and that means it's going to be the top of the list of your materials because pretty much that's what your wing is made of. So all we need to do, if we click close, it should be done. So now it's changed the material to 5mm white foam board, and it's changed colour slightly. We could try changing the colours, but actually the main thing is there it says it's 5mm white foam board as the material. So we need to do that to all our other parts. Let's save this one. So we've got our rib here, material, right click, 5mm white foam board. It's done. Spar, 5mm white foam board. That's done. Rear spar, 5mm foam board. Save. Leading edge. Oops. Trailing edge flap. That's the one we've just done. Okay, so we've done all our materials. So when you come to use them, just check that you've got whatever you called your material there is in it. Great, so we've got all our parts made. And if we just go back to this sketch, just remember what we did. We took the shape of this curve from Excel, the points that made this curve. We brought it into Solidworks, imported it via a curve, turned it into a sketch. Then we did our work on the sketch, adding in all the different bits and pieces, putting dimensions on, marking some centers. We did the thing using offset entities to get these offsets, using construction lines, and then we put solid lines to make all our parts. Used some equations there to help us use our dimensions more effectively, and then checked everything was watertight by trying to extrude it. And then we created new parts by putting this part into a new part and then using this sketch to obtain the geometry we needed. Okay, so good luck with that, making all your bits and pieces, and you'll certainly have to practice your skills in terms of generating sketches and generating parts, and see you in the next tutorial where we'll put all these parts together as an assembly.